Welcome YouTube. This is jseeb1 episode number 10. And today we're going to be talking about for Wisdom Wednesday. We're going to be talking about relays. And this gigantic thing is a circuit symbol for a relay. These things are basically relays. Let's just go through the different markings on it. I don't know if you guys could read that very well. But anyways. That's a 5-volt relay. Here's another 5-volt relay. Here's a 12-volt. Let's see if you guys can see this or not. No, basically it says 5A at 240 volts AC with 5 amps at 30 volts DC. And this is a 12-volt coil voltage. This is the same thing. But this one's a single pole, single throw inline switch. This one's a 12-volt DC one. All of these are basically the same thing, just different. And those little ones, which is the 5-volt coil voltage, which is rated for 1 amp. Well, here, let's just get back to the diagram that's drawn. This is labeled as coil pins. I-N-E. Coil pins, and what I was talking about, that was a plus 5 VDC and plus 12 VDC. That's basically the coil. That's what energizes this to pull this that way, which closes a circuit and allows electricity to flow through there, and it's bidirectional, which means it can go either way. But anyway, this is usually it doesn't matter, but this is usually pin 1 and pin 1. These are pin 2, pin 3. Usually. But it varies on the relay model. But this is the most common one, which is called a SPST relay. Now we got the coil VCC out. What a coil is. Basically, let's go through the theory. Anytime a wire is wrapped repeated like that, and then current is flown, basically that produces a magnetic field. Basically, that's how it works when currents flow through the line. And then that pulls, either that pulls or repels depending on the magnetic field. But then there's the switch. Since when this is pulling that way, let's just say it was pulling, this thing would close, and then this thing would be like in the closed position, which allows current to flow through the line. So basically, unlike a regular switch, which has to be pushed down or pulled up to disconnect or connect, or switched as it's called, Usually those are called S1s in circuits, or S2s, S3s, S4s, but it has an S. S represents switch. When there's four different kinds of switches. There's SPST, there's SPDT, there's DPST, and there's there's DPDT, which stands for single pole single throw. And that's where you get the SPST from. SPDT is single pole double throw. And then this one's a double. Jeez, I can't spell very well today. Double pole single throw. And then this one's a double pole double throw. And then that's the four different types. Complicated, I know. And those also go with a relay too. And then there's something called a latching relay. If I can remember correctly, I think it's I think the circuit schematic is but I think there's a diode in there, I think. Here, let's just see. Yeah. Basically, it's a coil that... Basically, a latching relay is a relay that holds its state. For example, like let's say if the relay had it open. When the current's removed, let's just say, since when that's in the open position because of that, let's just say you disconnect the line. Let's just say you disconnect the line. Then this thing, normally, since when it's spring loaded usually, that's a spring, would retract that back down to the closed position, which means electricity can flow through the circuit. Closed means it can flow through, open means it cannot. Complicated, and it's reversed. Normally you would think closed means it cannot flow through and open means it can, but it's the opposite. But see, normally that would go like that, but a latching relay, let's just say you pull that back down again. Let's just say you latch that and had it in the open position. Then you would remove the VCC, which is voltage constant current. Then that thing would hold that open, but then when you close it again, this thing would close and allow electricity to go through. And when you moved it again, it would stay, the line would stay in the closed position until you send current through it again. That's basically what a latching relay is. That's how it's spelled. Basically, a relay is an electromagnetic operated switch. That's what a relay is, basically. And then basically, a relay could be used in a wide variety of things. Usually it's for low voltage, low amperage, which is usually low voltage, low amperage, which is usually used for the coil. Which, if you remember correctly, this part right over here would be called the coil. It is, and it can control, depending on the type of relay and how much amperage it can handle. It could usually control HVHA. That's the highest. It could be, which is high voltage, high amperage. Which the HVHA would be inputted through this side and out this side, while LVLH would be inputted through these terminals. That just depends. Some relays, like this one, is a single pole, single throw, like we basically said. Let me just diagram this out for you. Basically, that's what's inside this relay. Common relay, usually. Which is this relay also. But this relay, this small little 5-volt coil relay, is different. You normally have the coil voltage, but then you have this. That little squiggly line is a spring, but you don't draw that in the circuit diagram. But there's 2 pins on this. This is the normally closed, and this is the normally open, and this is the common. And then this is coil. Three types of terms you have to remember. Which is common. Is the one that switches. It's basically the switch. NO means normally open. And NC, normally closed. But that depends on the type of circuit. Type of relay can vary. Basically, if you would have 5 volts coming in through this thing, it would go through this, according to the circuit diagram, and go out this one lead right there. But once you put coil voltage on that thing, that would switch, and then that would send current out through this line right here. So it just basically, whenever it switches, it switches from the normally closed to the normally open. And normally open becomes closed, and normally closed becomes open. Now let me define what I mean by open and close. You might think it's the opposite. Open means electricity cannot flow. And closed, which means electricity can flow. Like a battery. Let's just say that. A battery. Most common battery. It's open. Open circuit. Which means that's when there's no wires connecting it. But let's just say you had a battery, and then you just happily throw it, and then you just happily. The reason why there's a resistor right here is because I just normally throw that. It's because it's prevent a short circuit. It's called a short circuit resistor, or as known as a power resistor. No, wait, not a power resistor. Sorry, it's a load resistor. But anyway, then that would be called a closed circuit. Basically, and like those CCTVs that you hear about, that's a closed circuit television, which means that the TV could only be seen in the building. That's basically what that is. And then that concludes this video for Happy Wednesday, everyone. Please rate, comment, and subscribe for more videos. And please tell all your friends about this channel, that way it grows bigger. jseeb1 out.